Hi guys, in this video we're going to be looking at the standard enthalpy change of neutralization, the enthalpy change of neutralization using weak acids, and then we're going to summarize.
So let's start off by just defining what we mean by the standard enthalpy change of neutralization. Should be familiar with what an enthalpy change is, and we've got other videos on that if you're not, but the standard enthalpy change of neutralization is the enthalpy change when we form 1 mole of water from the neutralization of an acid with an alkali. We have to specify that this happens at 100 kilopascals of pressure and 298 Kelvin. So we're going to be combining one mixture with a pH of greater than 7, so this is our alkali, and we combine that with a solution that has a pH of less than 7, so that's our acid, and we're going to combine enough of these to form 1 mole of water. Now it turns out that if we use a strong acid and a strong base to do this, then the standard enthalpy of neutralization is always the same. It's always minus 57.6 kilojoules per mole. Now, as weak acids only partially dissociate, and by that we mean the acid will only release some of its H+ ions, the enthalpy change of neutralization is going to depend on how many of these H+ ions are released if we're neutralizing with a strong base. Now, when we use a weak acid, usually the majority of the acid is undissociated. We actually have very few of these acid molecules releasing their hydrogens. So we need them to have released their H+ ions, so we put energy in to cause this to happen. This makes it an endothermic reaction. So we've got our aqueous acid, which is weak, and we're going to be putting energy into this, which makes it endothermic, and this is going to break down this aqueous acid into gaseous ions. This may not seem very physical, but if you watch our video on the enthalpy changes of hydration, you'll understand that this is just a way to deal with the energy changes. So we put in energy to split all of our acid up into ions, which are gaseous, and then we consider the next step, which is to hydrate these ions, and this is going to release energy. The reason this releases energy is because new bonds are formed between the ions and the water molecules. These new bonds give out energy when they're formed, like all new bonds do.
Hey guys, to continue watching this video and unlock hundreds of other super concise exam board specific A-level chemistry videos, just click the Snap Revise smiley face here. Join me today, and together let's make A-level chemistry a walk in the park.